Um, as Joe said, the title of the presentation today is From Homes Passed to Homes Connected, Cabling Considerations for Outside Plant Fiber to the Home. Before I get into the meat of the presentation, just want to elaborate on Joe's great introduction of who HFCL is. We're new here in North America. We've only been active in the North American market for a little bit over a year, but as a company, we've been around for a while. The picture on the top left of the slide is our manufacturing campus in Hyderabad, India, in South Central India. It's actually an out-of-date photo. It shows our original draw building and our cable plant at that campus. Actually, if I had a current drone picture right now, it would show that the size of the fiber draw building is more than doubled. We are expanding our fiber draw capacity from 12 million fiber kilometers a year to 34 million fiber kilometers a year by the middle of next year. Company's over 37 years, started out as an engineering, planning, and construction company building telecom networks in India, but has backward integrated into cable and fiber technology, regional offices, 7 countries around the world. We've sold our product in over 60 countries worldwide. We have 5 different manufacturing plants across 4 sites in India. And our cable capacity right now is quite large, and we're expanding that by the middle of this year as well across our 3 cable factories. Quick overview of today's presentation. First, we'll review the current state of FTTH here in North America, do a brief review of PON topologies for FTTH distribution, and then discuss the meat of the presentation is going to be design considerations for selecting drop cables for the home or business connection. And the 2 critical questions to ask are, what's the right of way? How am I going to get there? And then how will the drop be terminated, both at the distribution end and at the subscriber end? So the Fiber Broadband Association, which HFCL is a member of, just published their updated state of the FTTH business at the end of last calendar year. We're up to 78 million home passings, 9 million added last year, despite the market in general being slow. And the take rate on average is about a little over 45%. So we've already got about 35 million unique homes on FTTH. Including mine. The forecast, and here's some more data as we actually go from putting in the distribution networks to actually connecting the individual homes, is that over the next 10 years, we'll get to 100 million homes passed. Estimated both public and private FTTH investment in the U.S. In the next 5 years, 135 billion. And on top of that, this isn't just the U.S. This is North America and Caribbean. Significant expansions planned in both Canada and the Caribbean. When the service providers talk about their FTTH plans to Wall Street and others, the metric that's been used for about 2 decades now has always been homes passed. I always talk about homes passed, and that's necessary to get where you want to be in building an FTTH network, but it's not sufficient. When you pass a home, you've spent a lot of money to build a distribution network, and you have an opportunity to win the press release and win your quarterly conference call with Wall Street. And here's 3 examples from last year. One is Wire3, a small ISP down in Florida, trying to get to 15,000 homes a month. Altice and their Optimum service in the Northeast talked about what they added. And then Frontier talked about adding over 1.3 million homes passed planned last year. So that's always what you see in the press releases. That's always what you see in the ISE newsletter and the other industry newsletters. But what's really important isn't passing a home. What's important is connecting a home. Connecting the home is what turns your investment into revenue for the long haul. What can you do when you actually hook up the home? Well, the first thing you can do is you can make some pretty happy customers. CableTV.com just last month published their survey of customer satisfaction. And the most satisfied customers were either FTTH or wireless. Starlink actually did pretty well, but I suspect that's because the people who are going to Starlink are going from DSL or no connection at all to having a reasonably fast broadband connection, though not as fast as what you can get from an MSO or from fiber. And the people who are doing 5G wireless connections also seem to be pretty happy as well, although I'll note that those 5G towers are all fed by fiber to the antenna typically. But the three of the highest performing service providers were fiber. And then just off that list, just off the bottom of that list, Verizon, FTTH, AT&T, fiber, or Verizon, Fios, AT&T, fiber are almost as high as these top five. And interestingly, all of the telcos providing fiber have better customer service ratings than the MSOs. The highest of the MSOs was Spectrum at 64%. So generally, customers are very happy with their FTTH service when they get there. But FTTH does a number of other things. You can deliver reliable service. The nice part about FTTH is it's completely passive from the head end or central office out. You're not moving electrons. There's a lot less to break. And customers see that as being the very best. In the Fiber Broadband Association survey, over 60% of potential customers see FTTH as the best possible service. The other thing that's interesting is once you get someone on FTTH, that's going to minimize churn. Their survey, the Fiber Broadband Association survey, showed that people are making net movement to FTTH and wireless and away from DSL and cable internet. And once they get on fiber, they stay because they're happy with the quality of the service. I'll do just a couple quick slides on FTTH distribution architectures. I guess the thesis of this presentation is that you've got your distribution in place and you have to figure out how to get to the home. But a quick review of how to get from the CO or the head end to close to the home is useful in this situation. This is taken with acknowledgement and thanks from Jim Hayes' website at the Fiber Optic Association. You should check this out if you haven't. There's some really great resources on that website and educational resources. And rather than reinvent the wheel, I tip my hat to Jim as I borrow from what he and his team at the FOA have put together. A lot of the original FTTH architectures were so-called home run architectures, where there was a dedicated fiber all the way from the CO to each premises. You'd run a multi-fiber cable to a splice point out in the field and then connect the individual fibers to the homes or businesses. What's become much more common is a so-called centralized split, where you run a cable connecting the central office typically to a splitter cabinet out in the field, and then typically you'll add up to a 1/64 split in the end, usually a 1/2 at the CO and then a 1/32 in the splitter cabinet. And then from that, you'll connect each of the individual premises. Although if you're going with a very short reach, sometimes you can do the split in the CO itself. Something that's becoming much more common is distributed split, or cascaded split, where you have different split ratio, or you have different amounts of splitting out in the field. You'll split a signal once and then split it again. Usually with again, you'll get to the similar kind of 1/64 split ratio, but maybe you'll do it by splitting 1/8 at the first splitter and splitting 1/8 at the second splitter. Then the final potential architecture, and there's actually a good article about this in the January ISE magazine, is the fiber tap or unbalanced split, where this is somewhat similar to a CATV architecture, where at the first drop point, you'll split off, you'll do a 90-10 split. 90% of the signal will continue down, and then 10% will be split to an individual customer. That architecture is becoming more common for rural FTTH, which is becoming more prominent with BEAD money and some of the other planning. Some of the customers that haven't been reached yet are in rural areas, and that might require a different kind of architecture. So this is a bit of an eye chart. I'm not going to read it, but just highlights the pros and cons and typical uses of the different architectures. Home Run, or a P2P point-to-point network, has the advantage of near unlimited bandwidth. Change out the line card and you can deliver as much bandwidth as the user wants. But it has the disadvantage of having a very high material cost because you need an awful lot of fiber, and a high labor cost because usually there's a lot of splicing involved. And it's actually not that common anymore for FTTH because of the expense. Centralized split is a good architecture. The advantage there is it's relatively low electronics cost because few of your optical line terminal ports in the CO get wasted. You have one port that goes to a 1x32 split out in the field, and you connect that to 32 homes. You might leave some of those ports open in the splitter cabinet if people don't take the service, but you end up not wasting ports. Another advantage is easy maintenance and troubleshooting because there's one spot where everything goes, and that's the splitter cabinet. Disadvantages, you're going to spend a little more on the cable, so you're going to need higher fiber count cable. One thing that a lot of municipalities, subdivisions, and the like have issues with is the cabinet itself. These are pretty big. They're the size of a large freezer, typically. And so where are you going to put that? Are you going to put that on the sidewalk? Or are you going to put that in someone's front lawn? There's often pushback on that for aesthetic reasons. And there's typically a lot of splicing involved, and splicing is expensive. Best used in high-density areas and where you have a relatively low expected take rate because of the efficiency in electronics. Anyway, the distributed split, which is again becoming more popular, the good news is you can use lower fiber count cables, and you don't need the cabinet. You can use, everything gets smaller with low fiber count cable. Your splitters can be housed in splice closures or pedestals, and so it's maybe aesthetically more pleasing. There's also less splicing involved because there's less fiber. The disadvantage is that potential higher electronics cost. You can strand OLT ports depending upon what your take rates are. And also the maintenance and troubleshooting is harder because you have to trace signal through the multiple splitter points. Most common use is medium to low density areas in suburban and rural areas. It's also a convenient architecture for MDUs, although I'm focused on outside plant in this talk. You can put the second split in the basement of an apartment building or on the premises of a, say, a townhouse development. And if you have a high take rate expected, then you'll use your electronics efficiently. The fiber tap or unbalanced split approach, the good part's very low fiber count cables, and therefore less expensive, and you can use very small footprint infrastructure when doing it. But it's probably the highest potential electronic cost per home, and it's the hardest troubleshooting because there's so many different split points where things are going on, and if you have to, it might take you a while to localize the break to repair. And where it's typically used is the low density urban areas, or, sorry, low density rural areas. Just to point out, typical cable selection for these distribution networks, centralized split, the general purpose loose tube type cables are most common. Flat ribbon may also be used, although typically in centralized split, your distribution cable will hit multiple splitter cabinets. And so the loose tube might be a little easier to work with because it's easier to do mid-span access. You can access one tube or two tubes at a time rather than doing the whole cable. And another thing we're seeing more of is micro cable that's jetted into microduct, and again, higher fiber counts. With the distributed split and fiber tap architectures, you can use lower fiber count cables, the general purpose or the micro cable. And one thing that you can even do if it's rural enough, or if it's a small enough area or rural area, is you can get into really small cables like a dry central tube loose fiber. What I'm showing here is a picture of a 24 fiber central tube cable that's very small, very robust, intended for direct burial. And that might be ideal if you're doing a fiber tap or a fairly low density distributed split area where you don't need a huge amount of fiber. So with that sort of quick review class of what the distribution network looks like, now on to drop to the subscriber. And if there's one thing to take away from this presentation today, it's that one size doesn't fit all. It depends upon the specific application, the specific area you're building, and what's important to you as a service provider. There's some value judgments to make about what the best way to reach the home is. These pictures are actually from my house. I'm in my home office today, speaking to you over an FTTH connection. This is the pole. It's in my neighbor's front yard with the power and CATV and actually 2 fiber to the home networks all running over it. And then this is the DMARC box and the cable running into my house that I'm speaking to you over right now. But the first question is, what's the right of way that you're going to use? Are you going to go aerial, buried, or in conduit? And then the next critical question is, how are you going to terminate these cables at both the distribution end and the subscriber end? And there's trade-offs associated with all of these, and the rest of this webinar will review them. So the first question is, what right of way? Are you going to go aerial, where the cable that's most commonly used is the dielectric flat drop, roughly 8 by 4.5 millimeters? Are you going to go direct buried, where you can put an armored drop in or a tonable drop in and hand plow it into somebody's yard? Or are you going to try to use a microduct type solution where you might use a blown fiber unit? It's not even a cable, it's just a protective tube for fibers and small plastic. These are all options depending upon the specific requirements of where you're installing cable. Each right-of-way has a different advantage and disadvantage. Aerial, and this was just emphasized by the most recent Fiber Broadband Association study that came out actually this month, aerial is going to be your lowest cost to build. Right now in the U.S., building aerial is less than half the cost of underground, based on the most recent Fiber Broadband Association study that came out last month. And it's going to be the fastest. There's nothing to dig. You can get the bucket truck out and go pretty fast. The disadvantages are aerial just isn't as reliable as an underground solution. You've got wind blowing over poles. You've got ice. There's probably going to be ice in the northeast U.S. today. Heavy wet snow from Pennsylvania to Boston. Trees fall, branches fall. That actually a tree fell in my front yard and took out my drop cable in 2020 or 2021. In more rural areas, you run in, or in suburban areas, you run into squirrels and birds that can damage the cables. And occasionally, we even have people taking a shot at a bird on a wire and causing shotgun damage. And then aesthetics are sometimes a concern, especially in sort of planned subdivisions. People may not like the pole infrastructure. They may want everything buried because it looks nicer. Direct buried does have the advantages on once you get it deep enough, it's going to be pretty much resistant to weather, and the aesthetics are going to be better because everything's going to be hidden. It's going to be higher cost, and if you direct bury the cable, you're going to have some potential issues with burrowing animals like gophers and moles and the like, and also vulnerable to damage from dig-ups and cuts. Duct for FTTH, it's going to be the most reliable. You have 2 layers of protection between the fiber and the world, the jacket on the fiber itself and the duct. Another advantage of having a duct is you can do a rip and replace. You can pull out the cable that's in there and install another one by jetting or pulling or pushing. And of course, the aesthetics are good. But it's going to be the highest cost. There's 2 passes. First, you've got to put in the duct, and then you've got to come back in and put in the cable. In many cases, it may make the most sense to do duct if you're doing something that's truly greenfield, that you can put the duct in before the sod gets laid in a new subdivision, for example. And it is, just because it's reliable doesn't mean that it's bulletproof. It's still vulnerable to dig-ups. It's still potentially vulnerable to animal attack. Taking a different case by case. If you're going with aerial, what's your span length and what's your storm loading district? The picture on the left is the NESC heavy, medium, and light loading districts across North America. Again, the dielectric flat drop shown in the upper right is the most popular cable for aerial, and one of the reasons for that is that you can get a really long span length, up to 100 meters in NESC light, in a pretty compact package with this cable. And those span lengths, even in heavy, are typically enough to cover almost every possible use case for aerial installation. But there are options. There are round dielectric drops available that are smaller and don't have the stiffness and preferential bending of the flat drop. I've heard people tell me, I love the flat drop, it's almost indestructible. And people tell me, I hate the flat drop. It's too hard to bend, too hard to work with. So a round drop could be an option if you find that the stiffness of the flat drop is too much, but the span length isn't as high. It's going to be, depending upon the loading district, anywhere from 1/3 to 1/2 the span length. On the other hand, a round cable has the advantage of no preferential bend. Slack coils will be much smaller. Reels will be much smaller. Weight will be smaller. So if you are in a situation where your span lengths aren't that high, a round drop might be a legitimate option to consider. One of the reasons for the popularity of the dielectric flat drop is the wedge clamp shown on the right. That was originally developed for copper telephone drop, the so-called flat A-drop type copper drop, which actually my house had connected to the street when I moved in 2000. The clamp I happen to show is the Diamond Sachs wedge clamp, which is now made by PPC and has been around for over 50 years. And it's very reliable, very easy to use. People are familiar with it, and this flat drop is compatible with it. The round drop, you can't use the wedge type clamp. You'll have to go to something like the formed wire dead end clamp I show on the right. Those clamps are a little bit more expensive than the wedge clamp, but with reduction in material and the advantages of working with something round that's a little easier to bend, for an individual situation, that combination might be a better choice. Next, moving on to the buried right-of-way, questions you have to ask are, do you want to make sure that the cable is locatable or tonable, or do you want to go with an armored cable? There are choices again here. You certainly want to be able to find the thing after you put it in the ground. And I showed pictures of flags marking where the cables are and someone using a test device to locate where the cable is before people like the guys in the lower left come in and dig up your yard to put in a sprinkler system or put in a new water line or that sort of thing. Another concern about merely using tonable or going with armored is animal attack. The picture I show in the sort of middle bottom, that's the Plains pocket gopher. Back when there was still, the USDA could still do animal testing of cables. That was the reference animal that was used to test the rodent resistance of cables. They chew, they wouldn't eat the cable jacket, but they chew anything. If they don't chew, their teeth grow too much and they actually starve. So they have to chew to keep their teeth wearing down, like rabbits and other animals. If you're in an area where there's wildlife like that, you might consider a steel armor drop like the one on the lower right. It's bigger, it's heavier, but a piece of formed steel around the cable core is going to be the most robust thing against animal attack. But you might also go as an alternate. What's commonly used is you can bury a flat drop that has a copper wire that's attached to the main cable by a web. So if you're less concerned about animal attack, the copper wire could have lets you find the cable. And it also, that figure eight structure has the advantage of, with the dry armor drop, when you touch the house, they're going to have to bond and ground that cable. And that's going to take more time and cost more money. With the tonable drop, you simply peel the, you can peel the wire away by hand, snip it, and you don't have to bond and ground at the house. So it's a matter of which way you want to go. The armored drops are going to be most invulnerable to attack, but they're going to be bigger and heavier and require a little more labor to install. One thing we did to try to illustrate how tough these cables are is I went to the folks in the lab and said, let's test some of these guys to failure. Let's really destroy them and compare what the standards say to what these cables are capable of doing. So we did abusive test to failure of the crush resistance and impact resistance of typical buried drops. The first one we did was the dry armored round drop. The American National Standard for Drop Cable, ICEA 717, requires that you expose the cable to 100 Newton, which is about, I'm trying to do math in my head, about a 20-pound crushing load over, or a 200-pound crushing load over a 4-inch wide plate. You do that for a minute, and then you back off, drop the load to half that for 10 minutes, and then measure the signal loss. And the signal loss can't be more than 0.4 of a dB at 1550. So I said to the guys in the lab, let's test this sucker till it breaks. We were able to take it up while measuring attenuation up to 600 newtons per centimeter, which is 12 times the industry standard load with low attenuation. When we went up to 800, we broke a couple fibers. So it'll do 12x the industry standard. It won't do 16. But these are very tough little cables. And the standard, the standard's there. It sets a minimum baseline, but these cables can go well beyond that standard. And there's a picture of it. There's a little bit of imprint of the crush plate on the cable, but it's intact. The flat drop is even tougher. It's got two big rigid fiberglass strength members where the round drop has fiberglass yarn reinforcements, and the two strength members almost act like the supports on a bridge, the struts on a bridge carrying the load. So we were able to take this one up to 16 times the industry standard load with low attenuation, and we barely failed in one fiber at 20 times the industry standard load. And you can see from the picture with the flat drop, it barely even notices the crushing load is there. Then in the spirit of, let's see where these things fail, and also when you have a lab, it's kind of fun to try to break things. We did abusive impact testing of the same cables. The requirement is you hit the cable with impact energy of 2.9 Newton meters at 3 different spots, which is you drop a weight from a 1 meter height in 3 different spots. The jacket can't crack, split, or tear, and same attenuation requirement. So for the 12 fiber dry armored round drop, we were able to go 2x the industry standard load. We actually had attenuation at 2.5x the load that was unacceptable, and we went to about 3x the load. We actually broke some fibers. But, it's taking a pretty severe impact event, as you can see in the picture in the lower right, and handling it. Where's my mouse? There we go. And again, the tonable flat drop is super tough with its two fiberglass rods next to the tube. There, we were able to go all the way up to 20 newtons per centimeter and get passing attenuation and no cracking of the jacket. At 5 newtons, you couldn't see that anything had happened. After 20, you'd see deformation of the jacket. We actually went all the way to 40 newtons per centimeter and had passing attenuation, but we started seeing jacket cracks beyond 20. And they weren't much, but it's you could argue, kind of look like a small split or tear after 20. So these are extremely tough cables if you put them in the ground. They do have decent resistance to, they're not perfect, but they're going to be resistant to dig-ups to a certain extent. They're pretty strong little cables. The third right-of-way to consider is, are you going to put conduit in? Again, if you're putting it in, you kind of want to be able to find it so that when the guys come in to put in the new water line, they don't cut your cable and trigger a truck roll. There's three different ways that you can find your conduit. One is you can put in plain plastic conduit and then put a tone wire with your drop cable. Another thing that you can do is use a duct with a locating wire where the copper is embedded in the duct, although I have had people tell me that, I'm not in the duct business and I'm not in the FTTH network business, but I have had people tell me that they have run into issues with the wire getting cut or also potentially breaking because the plastic stretches a lot more than the copper does, or the plastic and the copper stretch differently during installation, and sometimes it's possible to break it. And the other thing you could do is that you can throw in a tracer wire next to the duct. So those are all different options. It just depends upon what's most convenient for a given application. But if you put the wire with the drop cable, you know that it's with the fiber. Then once you have the conduit in ground, how are you going to get it in there? Get the cable in there. One option is to push or pull. You put the fiber on a caddy. There's some actually mechanically powered caddies, and you can pull it with mule tape or a pull string, or if it's short enough, you can push it. And in those cases, I've heard of people pushing flat drop into conduit. It's got to be a big conduit to accommodate the flat drop, because the flat drop is 8.5 millimeters wide with the without the tone wire, and over 10 millimeters wide with the tone wire. The round drop you can push in a smaller duct, although maybe a little harder to push because it's not as stiff as the flat drop. But one thing that's very common in Europe and becoming slightly more common here in the U.S., if you're putting the duct in anyway, is to use jetting. You can use very small jetting machines that are tabletop type machines that come in a little carrying case, a little briefcase, and can run off very small air compressors. And you could jet in a round drop, the 5 millimeter-ish round drop, or you could even get to very small conduit, 5 by 3.5 or 7 by 4, and then jet in blown fiber units that can be as small as 2 millimeters, 2.4 millimeters, depending upon how much fiber you put in. If you're going to pull the cable, where's my mouse? There we go. If you're going to pull the cable, these are, again, pretty strong cables. You can put a pretty high load on these before you run into something that fails industry standards. Unlike the crush and impact, we don't design these to sort of beyond the standards. Here we design to just meeting the standards because over-design means more raw material and means higher cost for everybody. Again, the round drop and isn't quite as tough or doesn't quite have the strength of the flat drop. This is a plot of fiber strain versus tensile load for the two cables, where we essentially put it on a test bench and pull it, and we have a special instrument that can measure how much the fiber is stretched. The fiber is tested in our factory to 1% strain to make sure that every single inch of fiber is tested to that 1% strain. And then the recommendation from the industry is that the fiber strain at rated installation load be under 0.6%. And that gives a 40% safety margin against what the fiber has been screened to in the factory, because not everyone else out in the field is putting a dynamometer on the cable and measuring exactly how much force they're using. Sometimes they pull it a little harder than the recommendation. But in this case, for a hand pull or even a winch pull, these have a tremendous amount of strength for their small size. The round drop cable, you can pull it out to about 120 pounds of load before you hit the fiber strain limit. And the flat drop, by the nature of what it is, it's got much more strength member in it. The official rating for this cable is 300 pounds, but you can pull it out to about 350 before you hit the fiber strain limit, or you can pull it, I'm sorry, to about 325. If you're using a winch pull, a breakaway swivel that breaks before if you exceed the rated load is a pretty good idea. If you're pulling by hand, you don't need to use a breakaway swivel because you're going to, even if you've got the biggest bodybuilder, weightlifter guys pulling the cable, they're not going to be able to pull it hard enough by hand to threaten the mechanical integrity of the cable or the fiber. Problem with my mouse. Give me a second. Okay. Last potential option is jetting. We have a jetting test track at our facility in Hyderabad, India, shown here, and a Plumataz Ultima Z25 battery-powered small unit. And we have a number of different blown micro units that work in this application. Here's an example, actually, of something we did last week. Jetting performance of a 2.4 millimeter 24 fiber unit. We're going into 8.5 microduct. It uses a jacket that we developed and manufacture ourselves. We were able to jet it 1,000 meters in 10.5 minutes with relatively low force. Final thing to consider, and I'll try to wrap this up quickly, how do you terminate these guys at the distribution end? And the questions you need to ask here are, what's your loss budget? What's labor availability like? Even now, with things a little slow in the industry, unemployment overall is pretty low. What's your CapEx budget, and what's your project timeline? How fast do you need to go? If you're using fusion splicing or field connectorization, whether it's splice-on or mechanical connectors, any of the bulk cables we've talked about could work. But another option, extremely common, is factory connectorization. In some cases, people use the hardened connectors, like the OptiTap style, and there's some new hardened connectors on the market, and plug them into terminals that are installed on poles or in pedestals. And these are weatherized hardened connectors that you just screw in and don't need a separate enclosure. But in other cases, people use traditional SCAPCs and put them inside weatherized closures that seal. This is a picture of a 4.8 millimeter round drop with an SCAPC on it. We can directly mount that connector on that cable. And then how do you do it on the customer end? You ask the same questions about loss budget, labor availability, CapEx, and project timeline. Again, if you use fusion splicing or field connectorization, any of the bulk cables can work. Or you can use the hardened connector or the SCAPC or other types of indoor connectors. Any of those could work. What are the pros and cons? Fusion splicing is going to be the lowest attenuation and highest reliability. And you'll be able to do a precise cable length with minimum slack storage. But it's going to slow down your speed, it's going to raise your cost, and raises a concern with labor availability because fusion splicers are typically highly trained and highly paid. The advantage of biggest advantage of field connectorization is you can get a precise cable length with minimum slack storage. You still run into the kinds of problems you have when you have a connector. Slightly higher attenuation, although in most cases that higher attenuation won't threaten the system loss budget. Cleaning the connectors, there's a little more labor involved to terminate in the field. And if you're using a splice-on connector, you're still using a trained splicer to put the splice-on connector. Mechanical connector, you don't necessarily need that level of skill, although there is training involved. And then the third option is factory connectorization. That is your fastest deployment option. It's plug and play, and therefore it's going to be the lowest labor cost. However, if everything's factory connectorized, one big issue you run into is slack storage or Installers there, they've got the wrong length on the truck. They've got a 100-foot length of cable, and the cable needs to be 103 feet to fit the application. Or they put a 150-foot cable in, and they've got to figure out what to do with 47 feet of slack. In addition, connectors aren't free, so it's probably going to be a higher materials cost, especially because you're paying labor for someone to put that connector on in their factory. The last piece, how do you get into the house and connect the ONT? There are two options here. One that's most common is having a demarcation box. That's the demarcation box on the side of my house where it transitions to an indoor-outdoor cordage that goes through a window frame into the basement. But another thing that's common is cordage inside. It's a picture of a flat drop that is a 3mm riser-rated cordage inside. You can also do a round drop with a riser-rated cordage inside. You can use common tools to slit the jacket of the cable, whether the round or flat cable. This is the Jonard flat cable slitting tool, and expose the cord. And then you can just push the cord through the wall. And from a fire safety point of view, you're legal to bring it into the house as far as you want. Advantages and disadvantages here. The advantage of the demarc box is that biggest advantage is you can troubleshoot and repair the outdoor network without having to get inside the premises. And you also have an optimized cable for each job. You have an outside plant cable going into the demarc box and an indoor cable coming out of the demarc box. The problem with it is you've got more stock keeping units. You've got to have both outside plant, inside cables. You've got to have the box itself. So there's just more parts to manage. The cordage inside approach, well, you've got your indoor cable and your outdoor cable together in one unit. But if there's troubleshooting required, you're probably going to have to get into the customer premises and have the customer be home in order to fix it. And also putting a cordage inside an outside plant cable just costs more than having regular fiber in there. And if you've got a really long length run, that might add up. So to summarize and give us some good time for the Q&A, considerations to think about when selecting a drop cable to the fiber to the home. First, what's your right-of-way? Are you going aerially? Are you burying it? Or are you going through conduit? For aerial cables, you need to consider span length and storm loading. For underground cables, you have to think about how are you going to find it and how rugged does it need to be for the specific environment. Termination, the options include fusion splicing in the field connectorization, and factory connectorization. You need to think about your system loss budget, what labor is available and what their skill level is, what your CapEx budget is, and what the project timeline is. Do you need to be fast or do you need to minimize cost? Those can be a trade-off. And then the final thing to consider is how do you actually get inside the home with the cable? Do you use a demarcation box and transition to an outdoor-indoor cable, or do you use a cable that has the inside plant cable inside? Final slide about HFCL. We do stand ready to be your low fiber count cable partner. We offer drop cable solutions for any right-of-way. All of the cables I showed pictures of are cables we make and offer in the North American market. We offer everything with the optional tone wire construction for location. We can offer the cables with 250 micron fiber for fusion splicing, 900 micron fiber for factory or field connectorization, or 3mm cordage to go inside the house. We offer fiber counts all the way up to 24. We're willing to customize color, size, added tensile strength is something that we specialize in. We are focused on this business. We have 24 manufacturing lines across our 3 factories dedicated to making FTTH cables, world-class G657 and A1 and A2 type fibers, and world-class quality. We try to deliver value for our customers. So thanks all for your attention, and I'll throw it back to Joe to manage the Q&A.
Thank you, Peter. That was exceptional. I really appreciate